So should I take over now?
Yeah, Professor Bhattacharya, you can start.
Oh, okay, fine. I'll just share my screen. Just a minute.
Yeah.
Can you see my screen?
Yes.
Okay, so welcome everybody to Responsible AI for Social Empowerment, RAISE 2020 Virtual Summit. And this is a global artificial intelligence summit organized by the Government of India in partnership with industry and academia. This summit was inaugurated yesterday by Honorable Prime Minister Shri Narendra Modi, who amongst many other things stressed the need for bringing down the language barrier. Another speaker in the inauguration, Mr. Mukesh Ambani, he stressed the need for building the digital capital, also known as data, the new oil. Now, all of us know the proverbial Tower of Babel. So today's RAISE 2020 session on bridging communication and linguistic gap shows that the need to reach out and connect has remained as real and as critical a need as in the yore. Gods up in the heavens supposedly created languages as a barrier to communication and thereby deter those audacious humans who attempted to reach the heavens in their mortal body by building the Tower of Babel. These souls could not communicate, and so their project failed. So this underlines the importance of bridging the communication and linguistic gap, without which actually nothing can move forward. So that is the motivation behind this session. And today's schedule is that we'll first have keynote address by Professor Raj Reddy. This will be followed by a panel with the same topic as the topic of the session, namely bridging communication and linguistic barrier with the help of voice-enabled AI. The panelists are myself, I'll be moderating the panel, then Professor Sangal, Dr. Kalika Bali, Dr. C.V. Jawahar, Dr. Bhiksha Raj, and Mr. Vivek Pani are the co-panelists. We'll also have comments and questions by the audience. This will be followed at the end by a demo cum presentation by Dr. Mitesh Khapra. Now, I am with the Faculty of Computer Science and Engineering Department at IIT Bombay. I am the host of the whole session. It is my great privilege and pleasure to introduce Professor Raj Reddy, who is a doyen of computer science and artificial intelligence. Dr. Raj Reddy is a pioneer of artificial intelligence and has served on the faculty of Stanford and Carnegie Mellon for over 50 years. He was the founding director of Robotics Institute at Carnegie Mellon University. He is the first person of Asian origin to receive the ACM Turing Award in 1994, known as the Nobel Prize. One of the founders of the American Association of Artificial Intelligence and was its president from 1987 to 1989. In a few minutes, we'll have the keynote address of Professor Raj Reddy. But before that, I would like to introduce another leading light from our country, Dr. Rajeev Sangal, who is one of the four fathers of Indian language technology. He is the former director of IIT-BHU Varanasi and also of International Institute of Information Technology, Hyderabad. He has worked extensively on machine translation systems involving Indian languages and English. He is the president of NLP Association of India and a member of the editorial board of Computational Linguistics, Journal of ACL. A fellow of INAE, Professor Sangal, along with Dr. Vineet Chaitanya, Professor Dipti Mishra Sharma, Professor Uma Mahesh Rao, Professor Soma Paul, and others, has adapted Paninian framework to Indian language technology through Anusara project. Professor Rajeev Sangal will be a panelist. So now I would like to request Professor Raj Reddy to deliver his keynote address, please. I'll unshare my screen.
Thank you. Thank you, Dr. Pushpak. It's a great pleasure and privilege for me to be here and sharing the panel with you. And Rajeev, Sangal, and you have been kind of the leading lights of language technology in India. And so it's great that you will be able to lead this panel. So I'll share my screen and try to minimize everything else. So I know you'll see other things. I could go to, this is probably better. So my talk today is the same as the panel label, empowering the people at the bottom of the pyramid, bridging the literacy divide and language divide using voice-enabled AI. And at the bottom of the pyramid is about 3 billion people on the planet. And they happen to be the largest and the poorest socio-economic group. And about of this 3 billion, it is estimated about 1 billion can't read any language, not just English. And most of the people in the bottom of the pyramid are semi-literate. That means they can't read and follow directions. They can't read a newspaper and explain what the article is about. And so in some sense, and they cannot use keyboard and touch-based computer apps. However, if you are a semi-literate person, the only available mode of interaction with the human beings is, excuse me 1 minute.
100.
Yeah, take that, take.
100.
The only acceptable mode of interaction with the human beings is by speech. I need to hide this floating controls. Now I'm okay. So the people at the bottom of the pyramid have not benefited from the information revolution. Every human being on the planet can hear and speak. If you cannot read and write English, computers and smartphones capable of speech-based interactions are essential for such population. The introduction of low-cost phones recently and the emergence of dialogue-based intelligent assistants like Siri and Alexa promise that we have the opportunity to make the people at the bottom of the pyramid first-class citizens. So India has, as you all know, major language problem. We have 22 official languages, and about 13 of them are over, at least over 10 of them, or 10, 12, are spoken by 40 million people or more. And of these people, depending on which data you look at and which year, anywhere from 25% to 50% are illiterate. And they have incomes less than $5 a day. And as a result, they have been ignored as a potential market. And for $5 a day times 400 million people in India, let's say, the bottom half of the pyramid that I talked about, the lower end, is about $2 billion a day. And so in a year, it adds up to 700 million to a billion to $1 trillion of market opportunity. So the idea that you should ignore them is silly. So my expectation is intelligent assistants using voice-only computing. There's no keyboard or touch or anything, such as Siri and Amazon, Alexa, will empower the people at the bottom of the pyramid. And today we'll look at the architecture needed to enable these intelligent agents to actually provide the dialogue-based capabilities. So speech-to-speech Indian language translation is not needed for the intelligent assistant. They need to understand whatever language you're speaking. Speech-to-speech translation goes beyond that. Not only must you speak, but you must translate it into some other language, from Telugu to Hindi or something. But here, it would just probably translate it into English, which is also a translation, just so that you can understand the dialogue. So if the intelligent agent, all the models are in English, then it has to be able to translate from local language to English, and then English back to local language to carry on a dialogue. So the tasks that we might, and I've looked at, which might be appropriate for people in a village who can't even read or write, right? These are, they're not going to be doing very elaborate, high-end apps that many of us might do, but almost everyone needs entertainment and education. And so that means videos that can be immediately, instantaneously dubbed into the local language and spoken out. So if you take a movie or a video from Khan Academy in mathematics, then if it can be immediately translated into local Indian language and then presented, then that would be fantastic. The technology exists. It has been demonstrated among major languages of the world, especially major business languages, not necessarily major languages, such as French, German, English, Japanese, and Chinese. Now, already they have such systems. In particular, recently, European Union conducted a competition to see if they can translate between all the 24 European languages in real time. And I was told that Microsoft was selected as on the basis of the competition. And so in any way, the technology exists. When I talk to them, what is missing is they don't have the data. The so-called data is the capital, is very central here. For every language, we need to collect about 100,000 hours of speech and 100 million words of text. And the question is, who is going to do that? How is it going to happen? Especially for Indian languages, no one else will do it. We have to do it. And that is where the problem comes in. And I won't go into all of these details because we have limited time here. The main point I want to make is these are, if you can make these voice-based intelligent assistant for Indian languages, they will become the killer apps. Everyone will use them all the time. Not only people that are illiterate, even I, for example, I use Alexa because I'm too lazy to type. And more importantly, I may be in bed, I might say, set an alarm for 6 a.m. or something. And all of that become possible, more flexible, using a voice-based intelligent agents. So I think once we demonstrate these things work very reliably, everyone in the world will use it, especially every person in India will use it. And that is the great opportunity here. So I'll come back to that.
Morning. Kate here.
Good morning, Kate. It's April 1st, 1997, and the time is 6:30 a.m. Kate News Selection reports new trade agreements between Japan and France affects Paris spring collections, plus 24 other items of interest. Care to browse?
Not now. Mail only, please.
Mail serve here. 43 items, including 26 unopened for 3 days, 12 unopened for 2 days, and
Cancel list. All right. I've been busy.
canceling. Were there further instructions?
Yes. Did my snap catalog arrive?
I understood catalog. Snap. Checking.
Oh, right.
Enthusiasm detected. Care to view large screen?
You bet.
Did that mean yes?
Yes. Switch to large screen.
Incoming good phone call. George Smith from Snap Headquarters, Priority 1. You wish to preview Mr. Smith. You've used that before. You care to decline it?
No, old call, preview call. Oh, now I smell trouble. Ugh. Okay, VidPhone, open connection.
Are you there? I'd rather see you.
Sorry, George, not exactly dressed for success this morning.
Seen the customer version of our spring catalog yet?
Yeah, I just got it in the mail. You guys don't exactly waste time.
You did one heck of a job, Kate. One heck of a job. I love that history of the t-shirt segment. Wonderful. Sales are.
Hey, cut to the chase, George. You didn't stay up all night to call and compliment.
Kate, you are the best interactive designer. I mean that from the bottom of my heart. But hey, I got a little emergency here. You know that blue jeans spectacular that you're working on?
Did you know that blue jeans were invented during the gold rush?
We don't have time for me to show the whole thing, but the important thing I wanted to share with you there is this video was made in 1990. And already people were thinking about voice-based intelligent agents. The whole thing is all speech only. The video part you can ignore. It was made to demonstrate the future chips will permit video conferencing, but also it had a set of imagined dialogue, which we don't even know how to do today. That is, if in the middle, you hear a word that you didn't understand, you say, what was that word? Can you define it? Between two people, it's easy. We do it all the time. We may not define it correctly, but at least something happens. We haven't yet done or demonstrated any of this functionality. In another talk, I go through each dialogue item and say what it is needed and why we don't know how to do it. But the important thing here is voice-based dialogues are extremely hard and require a lot of research. And however, and these are what is called a family of knowledge as a service apps. If you want to buy or sell or do any of these things, you need a domain-specific app that has that knowledge about banking or buying or selling or anything else. But underneath of it, there has to be a platform which understands language and understands dialogue and can actually communicate back and forth. And if that works well enough so that even an illiterate person can carry on a dialogue from a village and order whatever they need from Amazon or Reliance or whoever is going to be the major provider of online shopping, this will in fact transform all of them because all of a sudden, instead of depending on a very small shop in the village, now they can get a wide variety of products at the lowest possible price and increase their capability. So I want you to kind of think, many of you are experts in this area, think about how you would design such an app, voice only. You need a whole series of capabilities. First, at the bottom, you need the capability of accepting speech input and output and recognizing speech. And the speech recognition has to be in the local language. It's Tamil or Telugu or Gujarati or whatever it might be. And it must understand that language. And then it must understand the concept of carrying on a dialogue, including, clarification dialogue, namely, not everything will be clear. And there's a whole, you take a diversion from the main task at hand, so that if something is not clear, you go back and forth. I beg your pardon, what did you say? What do you want me to do? And all of that we do in human beings between two people. We haven't yet studied in detail. And again, if we can capture millions of dialogues every day, because their people are buying and selling online, and can use that data, then we can train the systems can learn by themselves. And that option requires some enabling legislation, so we are not violating any privacy and other things. And to get the language data, I calculated, WhatsApp is being used by 600 million people in India, or maybe more by now. And all we need is 1 minute of data from each of them. 600 million people, will give us, 600 million times 1 minute, about all the speech data we need. We need 100,000 hours of speech. If it is not one day, it may take a month. But so we don't need to listen in on everybody's conversations throughout. It's just a question of getting 1 minute. And those of you who have studied speech and language understand even that 1 minute of speech consists of breath groups. There's a spacing between the breath groups. You can actually break up the speech into breath group segments and then randomize them, so that even that 1 minute speech can't be heard as though it's a long conversation. So there's a whole set of things that can be done, provided we have access to the data. And so this becomes a central problem. We know how to do it. We know exactly what is needed. We know how to go about demonstrating such apps, but ultimately we don't have the data. So that's the underlying technology we need. Once we have it, the idea of one of the things, as soon as I saw Alexa, because I had seen this video that I just showed in 1990, it was already in the back of my mind, we need voice-based intelligent assistants like that. And so the reason it never happened, even when Siri first came out, you have to, press and hold or tap or something, and then it would kind of do something. Because the main reason was, if you had it listening all the time, you would run out of battery within a half hour or so. It's a power conservation problem. And so what the Amazon people, what they did was they kind of said, to hell with having it as on the phone, we'll make a separate device and connect it to the power source. So it's always listening, always on, always listening, always present, always working. Okay. So supposing we were to design systems that are always on, always working, and I don't know how many of the audience have seen Alexa, Amazon Echo. It's not very expensive these days. You should get one and play with it. But the problem is, it right now only works for English or maybe one or two other languages. I haven't kept up with it. And the problem is, right now, it requires a a prompt word at the beginning, wake word they call it, Alexa, then something. We don't do that. When human beings talk to each other, we don't say, Bhiksha or Rajeev, can we do this each time? We are talking, we keep talking, or, so it's still not anywhere close to where it needs to be to have a fully voice-based intelligence assistant that's as good as human beings when they have dialogue. And almost everything we do is based on voice-based commands. We don't type at each other. We don't tap at each other. Touch. We don't touch each other. We mainly speak. That's the only way we get things done. So basically, the design and demonstration have to be they have to have a number of properties. They have to be non-intrusive. That means they must be in a corner of a room and nobody should even pay attention to them. Autonomic, it's always working like your heart. And device independent. It's language, we are talking about. It's always on, always present, always working. There are not that many apps that can do that at this point. Amazon Echo does it, except its capabilities are very limited, very primitive compared to where we want to be. And it's always learning. It's a lifelong learning system. It's not only listening to you, but it's also listening to other people like you. And whatever, if one of them goes to the bank and does a banking application, that interaction can be captured, assuming we get around this privacy issue, and then with appropriate anonymization can be used by other people like you. You don't have to teach each app with each thing. So what we need are systems that monitor, analyze, and learn from experience. Learning from experience and experience of others is not yet being done. Even for Alexa, there's been already a major hue and cry saying you're always listening to what is happening in the office, so you're stealing my secrets of everything I'm saying, and they can, but they claim, and I believe they're right, they're true, that unless they hear the wake word, whatever is being spoken, it doesn't go beyond the thing. However, in the interest of making the thing, I think I'm running out of time here. So, there is much more stuff we can talk about, but I'll conclude. The issue is there's a cost issue and the economics issue and the necessary conditions of developing these intelligent agents. And there's a huge economic impact. We're talking about globally. We were only talking about India, but this problem is global. And of the $100 trillion GDP, we think 10% improvement in productivity will save $10 trillion. So they're business models. So in conclusion, 3 billion semi-literate populations in the world are a major untapped market. Effective use of speech technology and voice technology is the only option to support their needs. And we have all the necessary technology and tools, but we need the data. And this has to be done by partnership between government and industry and app development, which are a lot of, in every specific domain, buying or selling or banking or reading a newspaper or watching a movie and dubbing, they are all domain-specific apps. You need to capture the domain-specific knowledge, but that has to be built on top of the pyramid of a platform which understands speech and dialogue. And this becomes a very important and central part. And the people on this panel are world-class experts who have done this kind of thing for a lifetime. So I'm looking forward to hearing them. Thank you.
Thank you, Professor Reddy. Thank you very much for your...
So I'm going to stop sharing.
Yeah. There are quite a few questions, but I think I'll choose a few of them for your views on those questions. So can you hear me, Professor Reddy?
Yeah, please.
Yeah.
Go ahead.
Okay. Yeah. So one question which is very pertinent to current times is how do you envision voice-enabled AI solutions that might be leveraged in the context of future public health crisis?
I'm sorry, in the voice
Yeah, it's
enabled.
a sort of broad-based, open-ended question. How do you envision voice-enabled AI solutions that might be leveraged in the context of a future public health crisis?
I see. Rajeev, can you repeat the question? My sound here is not that good.
Oh, okay. Should I?
No. Let Rajeev just repeat it.
Okay.
Yeah. What they are saying, question is that there is this crisis like we had, pandemic. Now, in a future health crisis, what role do you think AI and speech technology can help?
Yeah. Okay. It's a very interesting and important question. In other talks I've given, mainly, I believe we can eliminate lockdowns completely using smart sensor watches. Okay. Assuming that comes to be, the issue is how do we actually make it happen? And almost every smartphone and every smartwatch has voice controlled capabilities, and that's how you can actually use the voice for detecting people are having breathing difficulty, for detecting if they're coughing and all kinds of things. But the problem is, again, the energy problem. If I have a smart watch on my hand and it's listening all the time to see if there is if the patient is coughing or having breathing difficulty or something, then that will consume a lot of energy, will run out of battery. So we have a whole set of systems issues and design issues, hardware design issues that have to be resolved. But all of them, once we have it, speech is the solution, even for pandemics and things. But you can also, one of the things that has been proposed is speech-based survey. Supposing you don't have a watch, right? You just have a smartphone. You simply ask the person once a day or once in 3-4 times a day, saying, are you having breathing difficulty? Are you having temperature? Are you having, all the questions that you would ask, a doctor would ask, and get responses from them. And then immediately diagnose based on the thing, assuming they're telling you the truth, then saying you should kind of quarantine yourself, self-quarantine in the house, and don't touch anyone and wash your hands, or whatever you would do. And this way, you can actually control the spread of the disease, infection, the R naught. All you need to do is get it below, 1 exponential growth, then it will die automatically, over a period of a few weeks. So I think there are a lot of opportunities for speech-based devices, smartphones and smartwatches, with the dialogue-based speech to help in the healthcare sector. Not just pandemics, but all kinds of things. Any problem you might have, you can conduct an interview, and based on the interview, you either connect with them to a real doctor. That's what happens now in call centers. The call centers directly go to a doctor. Assume that you have an intermediate agent which is able to kind of diagnose 80-90% of the problems and send you the medicine. Then the doctors only have to deal with the 10%. Dr. Pushpak, sorry, go ahead and the next question.
Thank you. So I'll ask you another question. In the interest of time, maybe only one more. So this question is there a potential for bias on the basis of language in AI-driven solutions? And how can we overcome this?
Yes.
Yeah.
So there is going to be a bias not only in the language. Recently, there was a paper about racial bias. What happened was they were training all these systems, speech-based systems and dialogue systems, and using data that they collected. Unfortunately, it turned out they did not have any black population there, or maybe if they had it one or two, it was mostly white. As a result, when they tested the accuracy of these systems, the speech recognition systems, the error rate for black population was twice as much, the word error rate. It was, for white population, it was like 17% or something. For black population, it was 35%. And so word error rate. Therefore, that means they can't use these intelligent agents. And so this happens throughout. And the only solution is very large amount of data and huge, and the other solution is statisticians have given us stratified sampling. That is when you, to know that you must sample, if you're doing this kind of data, if you want to reflect the population and not have the bias, you need to have, and the same would be true with respect to Indian languages. So if you speak one of the sparse language populations that are spoken by less than 1 million or so, there are a number of them, they are out of luck because the systems will not recognize them at all. And I don't know when and if the government or anyone, just like we have suffered, India and Indian language have suffered globally. And I used to complain to my friends at Microsoft, why is it you have a word working in Chinese and Japanese, but not in Hindi? They said, no, everybody in India speaks English, so that we don't need it. So this is the problem. The biases come in all kinds of ways, and they also don't have the resources to do everything. And the same thing will happen when we come to Indian language, voice intelligent assistants. Languages that are kind of sparse or rare, or even, they may not even be rare, they may be spoken by 1 million people, which is not small, but they will not get their share, they won't get the benefit for a long time. Ultimately, it might happen. And the problem is processing 100,000 hours of speech for each one of these things is a huge computational effort. In huge cloud computing, it takes like 10 to 20 days just to process and learn the language models and the speech models. And you can't afford to do it over and over again. And I'm sure people like Bhiksha are working on incremental deep learning models where I can keep adding 1 hour of speech to already existing one. And that's where we need to go, because you can't afford to retrain the entire system over each time. So there's a lot of research to be done. But at the same time, I think we need to keep the goal-directed focus. And there's so many language problems we can all study, and linguistic problems, and Pani grammars, and all kinds of things. But the important thing is, what can I do with it? And one of the things I've asked, I was working with Dr. Rajeev Sangal and IIIT, is, look, there's this Wikipedia in English. It has 100 times more things. Why can't we provide it in Indian languages? And but it turns out translating all of them requires a skill that many people don't have. Most people in India, they may know English, but they won't know local language. And they would have all gone to English medium schools. And if they may know Telugu, or Indian languages, they won't understand English. So you need someone who understands both to translate even a Wikipedia page. And so the great thing is the Google Translate now has a button, if you have a Chrome browser, which says, translate this web page. And when you translate that web page, it is not perfect by any means, but you can get your translation in every Indian language, all the major Indian languages, which is fantastic. At least you can read it and ignore all the problems and then see what it's saying. And if you're sufficiently motivated, you can then even go correct it and resubmit it as your contribution to Indian language Wikipedias. So there are lots of opportunities, but we need to begin, and then the government has to figure out how to encourage such work. Dr. Pushpak, go ahead. I'm done.
Thank you very much, Professor Reddy. I don't think we have now time for more questions. No. There are a panel discussion, and then there is a demo and presentation. Thanks a lot. Thanks for your time. If it was an in-person event, we would have given you a bouquet and we would have felicitated you after this talk.
I will be listening. I'm going to mute myself, but I'll be listening.
Thank you very much. So now we'll begin the panel discussion. And before we begin the panel discussion, Mitesh, were you able to solve that questions channel? Mitesh, are you there?
Yes, sir, I'm here.
In case you have returned. Yeah.
Yes, I was able to see the questions on the forum from the website. There were a couple of questions related to startups and so on, but I'll keep doing them.
Yeah, no, so what I'm saying is that we'll start the panel, and then at the end of the panel, I think I'll ask you to select the questions, or if you can somehow send them to me by mail. Okay, and then I can select. Okay. So I'll share my screen. Are you able to see my screen? Anybody?
Yes.
Yes. Yeah, okay. Okay. So now we'll begin the panel discussion. And as I had said before, the topic of the panel is same as the title of this whole session, Bridging the Communication and Linguistic Gap with Voice-Enabled AI. So I'll have a few introductory comments and then invite the panelists to speak in the following order. First, Dr. Kalika Bali, then Dr. C.V. Jawahar, then Mr. Vivek Pani, then Professor Sangal, and then Professor Bhiksha Raj. So kindly remember this on order. Kalika, Jawahar, Vivek, Professor Sangal, Professor Bhiksha Raj, and I'll have a few introductory remarks. This will be followed by comments and questions by the audience, which we'll try to answer as many as we can, keeping the constraint of time in mind. So now, before we begin this panel discussion, we remember this classic voice-based AI pipeline, ASR, NLU, and TTS. This is a very simplistic view, but surely the foundational pipeline. And on this, there are many, many embellishments. I have been concentrating on natural language processing for several years and realized that NLP, thy name is ambiguity, to borrow a phrase from Shakespeare. And natural language processing happens in many layers, starting from morphology, going through parsing, semantics to discourse. And at every layer, we have ambiguity. And we just now heard of languages which are resource-rich, languages which are resource-poor. So there is a linguistic dimension to the whole NLP problem. We have the language axis, the problem axis, and the algorithm axis. Finally, a problem is solved by an algorithm for a particular language. Now, deep neural networks have made their presence felt, like in image processing and speech processing, in natural language processing also. An interesting point is this layered processing of language and layered processing in neural networks seem to have a kind of correspondence. So if we take this sentence, no dogs please, depending on where we pause, dogs are welcome or not welcome. So now this goes through many stages of processing, starting from morphology. And at every hidden layer, we believe there is a kind of feature engineering going on, assisting the next layer in making decisions. Now, data plays a very important role because deep learning is very data hungry. And when we get data, to deal with the data, we have to invoke distributions and we have to invoke probability. Deep learning seems to say that the human thinking is not really pushed to the limit. There is reduced burden on human thinking. So algorithmic linguistic thinking may be less and less required because there is data and the instrument of probability. Data should shoulder more and more responsibility. And through neural network, non-parametric estimation has made its presence felt, unlike parametric estimation in classical machine learning, where an assumption is made about the underlying distribution. Now, an example which struck me as very interesting many years back, that if we have these two sentences, 3 rabbits corresponding to Troya Lapa, French, and rabbits of Grenoble corresponding to Lapa the Grenoble. So this can be looked upon as a parallel corpus. And in absence of any other clue, lexical, syntactic, or semantic, we can establish correspondence between words, which is called the word alignment problem. And simply because rabbits appears twice in the corpus, just like Lapa appears twice, we can seize this advantage of count and do expectation maximization over probabilities and expectations to have a situation where the probability of alignment of Lapa with rabbits wins. And this is the power of data coupled with some deep and smart algorithms in machine learning. When non-parametric NMT came, the Troya Lapa the Grenoble passes through the encoder-decoder framework and comes out as 3 rabbits of Grenoble. What happens here inside the network is the weights and threshold values are fixed. Where does the word alignment take place? Can you trace it to a particular point, just like in the phrase table in statistical machine translation? You cannot do that. So inscrutability increases. Another example is probabilistic context-free grammars, where the noun phrase is assumed to be consisting of determiner and noun 50% of the time. So this is based on samples and data, as Professor Reddy was saying. And if the sampling is good and we have large enough corpus, then we can have high confidence in this kind of probabilistic statements about the language. So data gives me the numbers, but my statement is about the whole language itself. So when we begin to plot the probabilities obtained from samples, we see that there is a kind of bell-shaped curve, which is showing that NP going to DTNN, determinant noun, hovers around 50% for the language. And if we increase the amount of data and not really the number of samples, then we see this saturating behavior where the probability settles around 0.5. And then there is this central limit theorem, which is called the crowning glory of probability theory, which allows us to apply normal distribution to any distribution which is underlying, provided we have large amount of data. And law of large number and central limit theorem are 2 sides of the same coin. So the purpose behind these remarks are that data and distribution come with a huge amount of power. Probability gives that power. And we apply maximum likelihood, maximum entropy methods to our benefit. But in spite of all these, explainability actually comes from linguistics, and wise, clever hyperparameter tuning also comes from linguistic insight. So we need both linguistics and data for doing natural language processing. Same is true about ASR, TTS, I believe, to a large extent. So with that background, I would now like to invite the panelists. The first panelist is Dr. Kalika Bali. She is a principal researcher at Microsoft Research India, working in the area of machine learning, natural language systems and applications, as well as technology for emerging markets. Her research interests lie broadly in the area of speech and language technology, especially in the use of linguistic models for building technology that offers a more natural human-computer, as well as computer-mediated interaction and technology for low-resource languages. She is a linguist by training and technologist by profession and believes that local language technology, especially with speech interfaces, can help millions of people gain entry into a world that is still now almost inaccessible to them. So over to you, Kalika.
Thank you, Pushpak. Thank you so much for having me as a part of this panel. Shall I share my?
Yeah, please do.
Okay. Okay, so I just wanted to throw a few numbers straight out. So 6 out of the 20 most spoken languages in the world are Indian. There are over 7,000 living languages in the world, and only 100 of them are supported by technology. If we kind of consider, like, Professor Reddy had talked about this bottom of the pyramid thing, there are only 15 languages which we can consider as having enough resources to build these really sophisticated language technologies that we keep talking about and hearing about all the time, all around us. None of them are from India. The 30 languages which we can talk about as more moderately resourced, and we have Hindi and Tamil, etc., as part of that. But there's a significant chunk right at the bottom, which includes many, many Indian languages and other languages of the world, which have absolutely no resource available that we can use to build speech or NLP technologies out of. So we did some work in our group looking at, like, how does this whole relationship between languages, the resources, as well as the technologies that are built on top of them, correlate with each other. And based on certain things that we did, we found that there are approximately 1.2 billion people in the world who represent nearly 88% of this world's population, language population, who have absolutely no language resources available, and therefore no language technologies are ever built to cater to them. And at the top of the pyramid, there are actually just 7 languages which represent 2.5 billion people and 0.28% of the total languages of the world, which have all the resources available. Now, this kind of thing, if we put it in the Indian perspective also, and we're talking about Wikipedia, etc., Hindi is the most resourced language amongst all the Indian languages of the world. And even that is, it's the 4th most spoken language in the world, but even that has a 55 rank. If we take wiki content as some kind of a proxy for, resources that are available for those languages. And as we keep going down amongst the most spoken languages in India, Odia becomes like 122 amongst the ranks. So this kind of a mismatch between the number of people that speak a language versus the resources that are available is like a really big gap that we need to bridge somehow or the other. Because to be able to truly support speech and language systems that can enable everyone on the planet, we need to kind of build systems in this environment, in this resource constrained setting. Because we cannot really go out there and say that, let's first do the data collection, let's do it first for Hindi, then we'll do it for Bengali, then we'll do it for Tamil. And by the time we reach Gondi and Santhali, etc., it'll be 10 years, and we'll have to wait till we have enough data for all these languages before we start building technologies that can actually help people, right? Speech technologies or language-based technologies. So we really need to think about how we can do this in the current situation where there is less data available, and how can we tackle this in terms of not only innovative ways of data collection, but also in terms of what kind of models that we need, what kind of algorithms that we need, what kind of applications that we need, and think around all these axes to be able to cater to all language communities. Now, the other thing is that, we've talked a lot about the kind of and how there are all these wonderful technologies that are becoming really prevalent, and deep learning is one such thing. We have all these massively multilingual models like Embert and Extreme, etc., that people think, in NLP, etc., people keep talking about how they're democratizing AI, right? And I have a very different view of what democratizing AI means. So when people talk about democratizing AI in this context, they think that, oh, we don't need experts anymore. Democratizing AI means that there's models, anybody who wants to can pick these up and start creating technologies and applications around them. For me, a true definition of democratization of AI is that AI is available to everybody, irrespective of the language that they speak. And can we then, using this AI, really impact low resource language communities? Right? And our work in this area that we have done around a project called Ellora, we do believe that building tech to amplify the voice of people is something that can be done. It's not like a pipe dream, or it's not something that we'll do it 10 years from now, but it can be done right now, right away. Because like Professor Reddy very rightly said, we know how to do this. There are just these blocks everywhere that we need to kind of, get out of the way. And the other thing that I think is really important that we as technologists forget completely lots of times is that, we have to look at the communities. We have to see what they want. We might sit in our AC rooms and, in our conferences and our discussion areas and think that, oh, we should create this technology and we should create that technology. I think that link with the community is extremely important to understand what the community's needs and desires are and work from there, right? So, this is a very, I really like this quote, which is that the L in NLP is language, and language means people. And that is something that we should never forget, that, L in language technology is also language, and we are creating this technology for use by the people. So look to NLP or language technology to assist people, identify who the stakeholders are, and always design to support the stakeholders' value. So in the end, I would just say that technology for low resource language enables communities. We have to tackle it from all sides, and we need unconventional thinking to make this happen. And start with Indian languages, expand to the world. Thank you.
Thank you very much, Kalika. Thanks a lot. So now I would like to, the questions we'll keep collecting, and at the end of all presentations, we'll take them. So now I would invite Professor C.V. Jawahar. Just give me a minute to share my screen. Yes. So is my screen visible? Jawahar, can you see it?
Yes.
Yeah. So I'd like to introduce Professor C.V. Jawahar. Dr. C.V. Jawahar is a professor at IIIT Hyderabad, and he has research interests that overlaps with computer vision, machine learning, and language processing. Professor Jawahar also holds the positions of Dean R&D and Amazon Chair Professor at IIIT Hyderabad. Dr. Jawahar will dwell on the profound change data has brought about in AI research and development. He himself has helped the community by releasing Roadtext 1K, text detection and recognition dataset for driving videos in ICRA 2020. So over to you, Jawahar. Should I share your slides, or you would do it?
I think I can try. Yeah.
You can try. Okay. Sure. Yeah.
You may have to unshare.
Yeah, I have unshared.
Can you see the slide?
Yes, I can.
Yeah. Okay. Thank you for inviting to be on the panel. So I would like to take the interface or the man-machine communication or man-man communication or human communication to multimodal. So we had seen how this interface, became more natural when we moved from text to speech interfaces. We are all very comfortable with now using speech, maybe for conversation with machine, maybe for conversation with our friends and colleagues. Now this lockdown also has suddenly brought a number of tools to all our electronic gadgets, which enables us to talk to our friends with videos. And we had seen that the information that we can convey, the message that we can convey with video is far more powerful than with only speech. And with speech, it is far more powerful than with text. I believe that one way the interfaces and the communication will emerge and move forward is becoming more and more multimodal. And if you look at this multimodal space, the prominent players of text, speech, and vision, and all these communities were widely different in the beginning. Now, the new wave of AI has possibly brought them much closer with the use of similar techniques. And we had seen tremendous success in improving the recognition. But is that enough? That is not enough. Possibly we need far more deeper understanding or perception or more deeper semantics of the messages to be understood in this space. And that is what possibly we are going to see over the next few years. And the present trend has been based on AI or deep learning or machine learning or similar techniques. How do they work or how do they succeed in this space? So the previous speakers had already raised or mentioned this issue that the performance of a solution is limited by the data that it is able to see. This is known. So you learn from the data and you evaluate on the realistic data. So you know the performance, how good or bad or the performance is. And this is how the machine learning is performing today. So if there is a bias, if there's a limitation that comes from this space, the deep learning has taken us to the next level where from the data, the powerful big blocks, a recognition block for speech or vision has we are able to build such big blocks of recognition. So you can look at this as data-driven solutions than the human knowledge-driven solution that we were coding for the previous year, in the previous years. Is it going to be the only thing that we are able to do? No. So people now talk about, can we use or can we learn from the data or the models or the knowledge that is available from somewhere else? Can I transfer the knowledge? Can I transfer the learned concepts? Can I transfer such skills from a resource-rich situation to a constrained situation where we are short of resources? So the way the AI has been moving is from the statistical probabilistic view to the deep learning view, what we talked about learning from the raw data, huge amount of raw data. Now we talk about, can we transfer such rich knowledge to limited situations where we don't have like a data available or resources available. This is very important in the Indian situations, in my mind. We have many languages, dialects, and as my previous speaker mentioned, we possibly don't have hope of getting enough data, tons and tons of data annotated, labeled for all this purpose. We need to learn on the fly. As Professor Reddy mentioned, we need to learn continuously. And there's an immediate need to do that. So is it possible for us to build and prototype solutions in such situations by exploiting the resources available elsewhere? And that is where the data-driven solutions and technology has to focus. And that is where I think the area is moving. So the data-driven solutions are that way a boom for Indian languages and in these situations. And I believe this has reduced the entry barrier for people. It has become much easier to enter into this space with less data, because we can learn on the capabilities of available somewhere else. The models, the algorithms, a lot of things can be borrowed very easily from elsewhere and build solutions. So I look at this as a blessing at this moment, and we should possibly exploit the power of it for our advantage at this stage. But is that the only thing that we should worry about it? No, there are a lot of things that we need to keep in mind when we see the success of the data. So in a way, the success that we see is an unreasonable effectiveness of the data. Just using the data, we are able to build solutions which we never thought we will see in our life. But what is important now in our situation is, how do we use the prior knowledge? How do we use the domain knowledge? And how do we merge these two paradigms to come up with solutions that are more effective? How do we look at applications that are possibly unique to our situations? What are the constraints that our situation is demanding on the applications? Maybe the applications that we need may be very different from that is popular in the West or some developed countries, and we may want to look at our own use cases. From a technology or a research point of view, our situation has also a lot of unique opportunities. The diversity and the wildness of our data and the problem space gives us a lot of unique opportunities to explore and to solve, and interesting challenges that the Indian situation is posing to the researchers, and we should just jump into it and try to solve it. That's all at this stage. Thank you.
Thank you, Jawahar. Thanks very much. So, as I said before, we'll take questions at the end. Now, let me invite Mr. Vivek Pani, and I'd like to share my screen for a few moments. You can see my screen, Vivek?
Yes, sir.
Yeah, okay. So it's a pleasure for me to introduce Vivekananda Pani. Vivek is the co-founder and CTO of Reverie Language Technologies, a company specializing in text and speech technologies for Indian languages. Vivek is passionate and dedicated to making usage of Indian languages easy on digital platforms. He began his Indian language computing journey at the Center for Development of Advanced Computing, CDAC, Pune, in the year 1997. His contribution has been on developing advanced multilingual tools for early computing devices and word processing software for computers, to leading today's state-of-the-art AI-driven Indian language technologies like automated speech recognition, machine translation, text-to-speech, natural language understanding, multilingual search, etc. So Vivek brings in the industry perspective to the panel. So over to you, Vivek. Would you like to share your screen?
I can do that.
Okay, thank you. Okay, I've stopped sharing.
Okay, hi everyone. before I start, I just wanted to make one sentence about AI. There has been this AI and ML that we keep talking about a lot. While let's say if there were two children, and we teach them both from a book, and the book teaches certain tricks, and after having given all the knowledge that is there, if we give a problem to both of them and see that one of them is able to solve that better and the other in not so good, or maybe in a different way. So we start thinking that one is more intelligent than the other. So while the learning may be the same, the information collected may be the same, but the intelligence that we perceive or see are different. So here, for machines, the intelligence is at its infancy. And what we have been trying is an application of this artificial intelligence, which is trying to make the machines learn a bit. And so we are just about there. So voice enablement here is probably one of the most influential or most pervasive, I would say, mode of communication. So because communication through speech is something that is used by everyone, like other speakers have also mentioned, unless one is impaired, infants begin to communicate by trying to speak. But most Indians are actually bilingual or trilingual, and we also see that voice communications are cultural. For example, in a typical interaction with a machine, a question about a yes or a no, is this right, or that is this correct? An answer to a yes or a no need not always be answered with a yes or a no. In Indian context, in different languages, somebody would just say a G or huh, or maybe just and so on. So those aspects of communication actually are cultural. The approach that I suggest is that when we have so many languages and there are such wide variations in dialects in India, it's a difficult problem to address, and they would need to be prioritized. To be able to prioritize, the things that we need to consider are, when we say voice is often also used to identify a speaker. So it's not only the text that matters, but also, the speaker is understood. But the speakers can be used only for personalizations, but it may not be suitable to try identifying a speaker for a transactional authentication. So it becomes important to understand what we must try, or we can try, and what we must avoid. So that would actually end up building trust on a voice-based voice enablement. Similarly, during when a machine is not able to understand or is likely to make an error, then machines do not have context or the intelligence that I mentioned. So therefore, the nature of error itself can be a lot more hilarious or at times damaging than the error rate. And therefore, a usage which has got more sensitivity towards the error rates cannot be relied on by using a voice-enabled. We also, to be able to address such large number of languages and dialects, I think distributed data creation is, like Kalika mentioned, is something that has to be tried with an open architecture. So we did an experiment with a group about 2 or 3 years ago in Hyderabad, where we wanted to create something for the farmers, a particular use case by taking some students. and help them with technology tools that would make sure that the data that they are collecting is actually useful by the machines and automated. So the automated validation itself helps collect the data, and they were able to create models very, very quickly. So people who were uninitiated into machine learning or the speech arena were able to create solutions for farmers in who are using special dialects into their community. So that sort of an approach would actually end up making the voice enablement reach much deeper than getting restricted into the major languages of our country. Of course, we have an advantage of having a large amount of shared vocabulary. If we go from the north to the south or from the east to the west, more than 70% of vocabulary commonality is discovered. So, whereas there are alternates that are also used in common spoken language, but if the shared vocabulary can also be standardized in different use cases, and a comprehensive word list is created so that the language models do not falter, then I think development of solutions will become much faster and adoption will also become uniform. Faster. The reason is that when humans interact with machines, unlike when humans interact with other humans, they tend to try and adjust and end up trusting when the machine behaves uniformly. So that way, I think this will make adoptions much faster. The last is, what is beyond the voice enablement. There are a few things that we must look at. Is the environments. Most of the field use environments in India are not silent. And the nature of noise is not predictable. It can't even be guessed within the laboratories. So therefore, the data collection points would mostly remain disconnected from the real use case. Similarly, the weight triggers that we spoke about, and with more and more voice usage coming in, and also a lot many devices coming in, if you really have a watch and a phone and your television and your air conditioner and your refrigerator and maybe an assistant and so many other devices in your home who are all listening to you, it would obviously become a lot more challenging. Apart from this, of course, the environments themselves will also end up creating challenges. So voice activity in different environments therefore becomes a thing to look at very, very closely. And then, of course, identity and personalization. There are so many debates that go around about data compromise or identity theft and so on. So the security aspects also have a lot of I would say potential barrier in making uses personalized, which is more desirable to make a voice enabled platform get better, because it is much tougher to create a solution that is absolutely generic and usable by many different variety of speakers than to have smaller modules that are able to adjust, like Dr. Reddy mentioned, by taking feedback from the user right there and personalizing to them and delivering a lot higher accuracy. So that has already been tested a lot, but delivering that becomes a challenge. So those are the things that I have mentioned. Thank you.
Thank you very much, Vivek. So now we would move to Professor Sangal. I have already introduced Professor Sangal. Sir, should I show your slides or you would?
These sharing is not working at my end.
Okay,
so
I'll do that.
Grateful if you can.
Yeah, I'll do that then. I'll do it.
Slide.
Yeah. Is the screen visible to you?
Yes, it is visible to me. Thank you.
Okay, I'll make it full screen mode. Yeah. Yes.
Yes. So welcome to everybody. I'll talk about language translation mission challenges and opportunities. Now, we've been hearing, wonderful things and ideas about what should be done, what can be done. So, Professor Raj Reddy told us that we must address the bottom of the pyramid, and so did Kalika also say that, and I fully agree with that. So there are two principles that I will use, that I will illustrate the, uh, in my talk. The first is that we must address a need that is very acute, and that is being felt by a very large number of people in our society. Number two, as we build technology to satisfy the need, uh, we should also be putting to use that technology. So these are the two principles. So on one hand, we identify a need that is real, that is being felt today by a large population. And secondly, as we build technology, we put it to use right away. So next slide, and that I'll now begin my talk. So if you look at Indian language content on internet, this is from w3text.com. What they do a survey of 10 million most frequently used visited sites every week and determine the language content there. Based on that, they estimate what is the size of language content that is available for a given language. So this data is slightly old, last year's data, and I went to this year's site also, but this part was not working this time on that site. They had put in some other things. So English has 54.4% of total content that is available on the net, and now it showed as 60%. So these numbers vary also. Now at rank 25 is Thai language, which has 0.3% content. Hindi comes a distant 37th rank with 0.1% of the content on the net. And this content is counted, I suppose, in terms of number of bytes. Then comes Bengali, Urdu, Tamil, Nepali, Marathi, Telugu. And if you total up all the Indian languages together, it is less than 0.2% content on the net. So this is the situation which we are facing today. Now, what this means is that Indian population today, which has gotten these smartphones, which is now able to access the net, access the web, suddenly has very little content available for it. And they see English content, for example, they take help in getting English content, but that is largely doesn't become available, doesn't become accessible to them. Next slide. So if you look at now content in higher education, then higher end education content on Swayam platform is largely or perhaps only in English. So Swayam platform, we are fortunate that India moved early on in creating content, in recording content, video lectures together with slides and other material. And this got placed on the Swayam platform. But unfortunately, it is largely and perhaps only in English. Very, very small part is in other language. The lectures are in English, the transparencies are in English, the reference material is in English. And there is a need to make all this available in Indian language. Number of users today for this content from Ministry of Education is that this is last year's figure, 25 lakh students who regularly see this content. And they say that if only, and they receive large numbers of emails, inputs, where students are asking, why is this not available in Indian language? Their own estimate is that in case this content was available in Indian languages, the numbers would be 1 crore. Okay? 10 million students would be accessing it for higher education. What pandemic has done school education has also gone online. So suddenly, these people who have become now more tech savvy at the younger age itself, they would be looking for their school content or other popular material, science, health, agriculture, education, technology. So all this material they are going to be looking for on the net, and Indian languages will have very, very little content. So this, I believe, next slide, is something that we can take on priority. How to create content in Indian language. So creating content, of course, may mean creating original content in Indian languages, certainly. Otherwise, and to get things done and get started fast, translate that content which is already there in English into Indian languages. And as you translate them into Indian languages, you can also start translating from one Indian language to other Indian languages because they are close and the translation might be easier. So this is the what something we can do. Next slide is now how do we go ahead and do this? So there are two methods. One is the voluntary method, and the other is, of course, the paid method. Voluntary method works on public recognition or coming from a feeling of social service for people who do things voluntarily. The paid method links with money or livelihood. Now, both these methods need to be leveraged and they should support each other. Next slide. And Professor Raj Reddy, emphasized to us the importance of making this kind of knowledge available to everyone in Indian languages. And he gave the example of Wikipedia, and he said, why can't we translate? Why can't we first select what needs to be translated from English Wikipedia and then have a process by which these things get translated? And this kind of content could be done through crowdsourcing. This is voluntary work. And the crowdsourcing by school and college students, they would translate content from English to one or more Indian language. And of course, from once it's available in one Indian language, it can be translated to every other Indian language more easily. And another example would be TED lectures. This is speech-to-speech translation of lectures. Now, this can be done using machine translation technology tools. It would also make use of speech-to-speech machine translation tools. I'm sorry. Can you? Am I visible? Yeah. All right. So my screen got shifted. So this can be done using translation technology tools, speech recognition technology tools, and so on. So how would we do this? And this was, I was, looking at numbers in Tamil Nadu. So these numbers are 3-year-old, based on 3-year-old figure, 1.2 crore or 12 million students in the school system. And if we say 60 lakh, half of them are from class 6 to 12. That means there are 60 lakh students. Now 5% of those students is 3 lakh students. So they become our potential resources who will do this translation. And for this, suitable contests can be run. And let's say out of that 3 lakh, we may get 30,000 young, energetic people who will be translators. And in that process, they would also learn the technology tools. They would learn ASR, they would learn how to use machine translation, how to make text-to-speech system better, and so on. So this is a man-machine combination. So the machine today cannot produce high-quality translation, which is of publishable quality. But machine can do enough work that the productivity of a translator can be increased by a factor of 2 to 3. And one of the goals we can set for ourselves is to increase the productivity of the translator by 10 times in the coming 6 years. So this would be a method by which, as we build the technology, as we use existing technology, as we improve it, as we are in the process of developing this technology, we also put it to use right away, because that will tell us where the technology lacks, where the effort should be put in. And on the other hand, we will see the results, the fruits of our effort coming out right away. So this would be the voluntary method, voluntary crowdsourcing method, by which we will generate large amount of e-content. And by the way, I purposely did not use the word as corpus. This is not just corpus that machine will use. This is content that people will use. So the quality of the translation, the quality of the output will be much higher. And certainly machine learning is going to use this as it becomes available. Next slide. Then I come to the second part, which is starting services, which will be paid services. So we undertake massive exercise to translate material in science and technology, in health, agriculture, administration, judiciary, and so on. And this would be paid for. So this could be lectures in NPTEL, Swayam, and so on. It could be websites of health ministry, agricultural ministry, and so on. So this material gets translated, again using technology tools, for which we pay. So there are these two parallel streams, one which is a voluntary stream, which is going to generate for us tens of thousands of potential translators. And then there are paid services for which their opportunities for livelihood become available for these people. In fact, for higher education in Swayam, we may actually make use of PhD or MTech students because they are domain experts. So while they translate, they also earn money. And the two streams, the two strands running parallelly would feed each other, and we would have set up an ecosystem, next slide, in the country. And this ecosystem will be based on a concrete need or a concrete demand. Example, concrete need would be Wikipedia, and concrete demand example I've given is e-content in government, administration, and certainly education. And the first part will train manpower in large numbers. This would be 100,000 translators. If we have 20,000 in Tamil Nadu, you can imagine that rest of the country, if we count similar numbers for other languages, we are going to have a few lakh translators. These are all volunteer translators. They are not looking for money. They are looking for recognition. But the work they are doing becomes useful. Out of this large set come out paid translators who also then decide to become professional translators or part-time translators who take up work for translation. And we'll be also handling speech-to-speech translation. And third part is that as the technology is developed to support this, it will be done jointly by academic institutions, startups, and established companies. And throughout of this will come out translation service provider companies. Also, there will be translation technology provider companies. And when I'm saying translation, I'm including speech as well as text. So this will also lead to setting up an ecosystem in which all these different components will flower. And if we can achieve this, we would have changed the course of language. And the languages, what this would mean, suppose even if we take it up for 20 languages, 22 languages, which are the official languages, out of that will come a manpower force, which will also say, oh, my mother tongue is not these 22. I have another language. And then they would also start creating content in other languages. So we would have put in place a movement, so to speak. And while building the movement, such an ecosystem will be developed, which will lead to overcoming the language barrier in our country for all time to come. We have had enough listening to that there is a language barrier. Let us now overcome it in this generation so that this issue becomes a solved problem forever. Thank you.
Thank you very much, sir. Okay, so now we'll move to Professor Bhiksha Raj. Just give me 1 minute. Just a
And
minute.
Pushpak, can you manage the slides from your end?
I'll do that. I'll do that.
Just
Just a
tell you
minute.
where to change slides.
Yeah. Oops, sorry. Sorry, one sec. Just a minute. Can you see the screen, Bhiksha?
Yeah, I can.
Yeah. So I'd first like to introduce you as a panelist. So Professor Bhiksha Raj is a professor in School of Computer Science and Engineering, Computer Science in Carnegie Mellon University. Professor Bhiksha Raj's research areas are automatic speech recognition, voice forensic analysis, audio intelligence, machine learning theory, and data privacy. The last mentioned topic is his major part of research, which is focused on privacy-preserving algorithms for speech and audio processing. Speech is possibly the most private form of communication, yet when a speech processing engine such as voice authentication system or a speech recognition service operates, it requires complete access to the voice recording. So over to you, Professor Bhiksha Raj. And I should operate your slides, right?
Yes, please.
Okay, I'll do that. Just a minute.
You can go straight to slide 3 because the first two are just introducing the topic.
Yes, right.
The previous slide, please.
Yeah.
Go back one minute.
Yeah.
Okay. So,
Is this the right slide?
Yes. Morning, all. So, again, thank you for inviting me to this panel. I'm honored. Let me start off by saying that I'm actually a believer in voice technologies. I've been working on this for 25 years. And so the fact that I'm providing a note of caution over here should not be taken as a critique. Now, we've heard a lot of what voice technologies can support. Primarily delivery of information, but really in governance, there are many other things that voice technologies can help with, particularly in a country like India, like in governance, accessing services, providing information, authentication and verification, even things like voting, in law and order, in reporting crime, identifying criminals, dealing with corruption, education. That's a big thing these days, remote instruction, finance has all the same issues as governance, healthcare, tracking mental and physical health of people, diagnostic tools, quality of life tracking. Every one of these is a part of governance and civic society that India has deficiencies in, and where voice technology could really help. But then before we dive headfirst into this, into voice technologies, we have to ask a few questions. Next slide, please. Can you go to, yeah. So the first thing is, can these technologies be trusted? Can you please play that audio? You should be able to click on the little arrow to the left.
Yes, I'll do that. I hope you should I again share your audio also? Just a minute.
Yeah.
I'll just share.
Okay.
Oh, it is already checked. Okay.
Yeah. It doesn't forget.
Last month, 20,000 migrant children were illegally brought into the United States, a dramatic increase. My administration has presented Congress with a detailed proposal to secure the border and stop criminal gangs, drug smugglers, and human traffickers. It's a tremendous problem. My administration is doing everything in our power to help those impacted by the situation.
So here, that is the voice of Donald Trump. He is the most powerful person on the planet today. it's spoken in exactly his voice, exactly his pronunciation, exactly his intonation, exactly his prosody, and it's synthetic. If you can do this to Trump, you can do this to anybody. Next slide, please.
Last month.
Yeah, so the previous one. Yeah, so here was, this was an article from last year, September 2019, exactly a year ago, where someone actually used voice mimicking software into fooling someone else to transferring a lot of money to themselves. Now, this is not just for obvious purposes like, faking voice, but you can think of the situation where pretty much in any voice-based service, you can speak the person. So a malicious entity has the ability to do whatever they want if things are not protected. So the first question is, can voice technologies be trusted? The next slide, please. The second one is, are they private? Now, when I want to use a voice technology, I want to typically, if it's just delivery of information, maybe it's more benign. If I'm using a service, then I want access to a specific aspect of the service. So I might be performing voice recognition and asking for something. Service, which could be the government, could be anybody else, now has access to my voice. And here are all the other bits of information that it can extract from the voice. The service now has my voice print. They can go and search for me everywhere. They can track my behavior. They know my gender. They know my age because you can predict that from the voice. They know my native language because no matter how carefully I enunciate, my native language comes through. They know my health status because my health status, as we all know, is reflected in my voice. And of course, so many other things that you can extract which were not intended by me to be communicated. What I really wanted to communicate was the basic sequence of words I wanted transmitted. And that too is accessible to the service. So the second question is it private? Next slide, please. And the third one is it believable? We hear so many things, so much about numbers, accuracies, performance. Is it good enough or is it hype? So when people will report accuracy performances on a voice authentication system, which is one of the most accurate voice-based technologies on the planet today, they're going to give you something like 1% equal error rate. Or if they're doing something like a health analysis system, they're trying to detect some problem, they're going to give you a number like this. It's got 60% true positive rate at 30% false positive rates. Now, these numbers look very good on the face of it, but what do they really mean? And it turns out that when you begin looking at India's huge numbers, those very good looking numbers actually end up being very bad. So let's consider a recent problem. Can you go to the next slide, please? I have some numbers here. I have to cite my source. This is courtesy Ramdas Menon's LinkedIn page, which is up there. He has a nice Excel sheet, which you can play around with, which gives you some interesting numbers. So let's consider the COVID-19 problem, healthcare. This has just been raised as an issue. The most accurate test right now we have for COVID-19 is the reverse transcription or real-time PCR test. RT can be translated both ways. And the best numbers that I have seen for the accuracy of the system, which I just picked up from the Lancet on 29 September, there's this article by Surkova, Nikolaevsky, and Drobnewski. They say that in UK, they achieve 95% sensitivity and 95% specificity with the RT-PCR test. What this means is when you say it's 95% sensitive, it means that if you do have COVID, 95% of the time, the test will tell you you have COVID. That's pretty good. If you don't have COVID, the 95% specificity tells you that 95% of the time when you don't have COVID, it will say you don't have COVID. That too looks amazing. In other places, the specificity numbers reported are closer to 70%. Now, you can improve these numbers somewhat by repeated testing, but you're never going to get 100%. Next slide, please. So let's look at India's numbers. According to the Worldometer, 0.07% of the Indian population is currently infected. So if that bar represents the Indian population, that little sliver to the left, which is in red, shows you the fraction of the population that's actually currently actively infected. Now, if we were to run tests randomly in proportion to the population, you would want to detect the entire green bar as not having COVID and the entire red bar, which is already exaggerated in this figure, as having COVID. Now consider a test which is far more accurate than the real-time PCR test, something that has 99% sensitivity and 98% specificity. Next slide, please. That would perhaps detect all of those people in the red bar as having COVID. So you're going to get that red bar, most of the red bar again. It is also going to detect 2% of the green bar as having COVID. But because the green bar is so long, so large, the actual number of people who don't have COVID, who have been detected as having COVID, is going to be represented by the second green bar there. So if you look at the proportion of people who have been detected by the test as having COVID, if you want to see how many of those actually do have COVID, it turns out that even for something so accurate, only 1 in 30 people detected as having COVID actually have COVID. 29 are false positive. This is for a real-time PCR test. Next slide, please. Where does voice come in? Now, when COVID sort of hit the world back in February, our research group began working on trying to detect COVID from voice, because COVID affects the lungs, and we assumed that there would be signatures. So currently we are working with a hospital system in Chile. We have hundreds and hundreds of patients. We aren't the only one. There are people around the world working on this problem. So the left is a result published by the Vadvani Institute recently. And the plot shows you how, now you can trade off the sensitivity for specificity. If you become more sensitive, you will begin accepting more non-COVID people as having COVID. If you want to be careful about not accepting non-COVID people as having COVID, then you'll begin rejecting actual patients. And so that curve shows you the trade-off. Ideally, you wanted to go straight up and then to the right. So the blue curve shows what Vadvani got. And the figure to the right is our best result. Again, I'm telling you this is our best result because the results actually depend on the cohort that you test. And so on the figure to the left, they achieve a 90% specificity sensitivity at about 40% specificity, which means that if they catch 9 out of 10 people with COVID, they're going to catch 4 out of 10 people who don't have COVID and tell them they have COVID. In our case, we have something like 99% sensitivity at 85% specificity on this particular cohort. Again, these are optimistic numbers. Those numbers look amazing, right? What does it really mean? It means that even for these carefully curated and lab conducted tests, only 1 out of 2, between 200 and 1,000 patients who have been detected by this voice-based system as having COVID will actually have COVID. When you hit the ground, it will mean that numbers are going to be much worse. That green bar, which are healthy people who are being detected as COVID, is going to be about 10,000 times as long as the red bar, who are the COVID patients who are being detected as COVID. And this is what we're going to get with the best technology we have today for voice-based COVID detection. Next slide, please. And so my presentation is brief. Here are the questions. First, of course, we are pitching a lot on voice-based technology. Are we there yet? And the answer really is no, because as everybody has mentioned, we don't currently have the data to even have the technology up where we can reliably present it as being ready for civic society and for e-governance. But the bigger question is, given the sheer complexity of the problem, will we ever get there? Or more precisely, will we ever get there before a better technology gets there? Secondly, even if it does, how vulnerable are we to malicious actors? Are we safe? Will we ever be safe enough? And if you say, I'm going to actually sort of take the risk, then will the cost-benefit ratio of what you lose to malicious actors to what you get from the technology, will that ratio be in our favor? If it's not currently in our favor, what will it take to get there? The third one is, if you ignore the absence of malicious actors, the privacy challenges, do those privacy challenges compromise us, and are they worth it? And finally, are we being oversold? In a vast population like India's, even a tiny, tiny error, like I told you, the 2% specificity of the RT-PCR test can magnify to economically and socially devastating magnitude. And voice technologies are nowhere the kind of accuracy, are currently nowhere the kind of accuracy that that would mean that we do not have these kind of costs. And so this question still remains to be answered. That's the content. Thank you.
Thank you very much, Bhiksha. Thank you very much. So now we have discussions based on the panel, and Mitesh has been sending me the questions, and I have been looking at them, and as far as possible, I have been assigning the panelist who could answer it. Now, the problem we have is that we are just 10 minutes away from the closing time of the whole session. So I have requested the tech team and the organizers to increase the time limit up to 9:30. That is another half an hour added. And Professor Raj Reddy would prefer having the question, answer, and discussions now. So we can have it. So Mitesh, you will get sufficient time. Is it okay with you, Mitesh?
Yes, sir, it's fine.
Okay. So yeah, so we'll spend about 15 minutes on the question, answer, and discussion. Is that okay, Professor Reddy?
Yes, of course.
Yeah.
Rather than answering questions about my talk, I would like to comment on very interesting panel presentations.
Okay.
I agree with everything that was said, and we need to somehow prioritize. One of the things we talk about in research investments is investment strategy. We have a limited number of dollars, and we need to kind of say, what are the things we should do tomorrow? What are the things we should do next month? What are the things we should do in the 6 months to a year? And what are the things we should kind of plan? We'll do it, but not immediately. And these are things this panel needs to offline kind of work with government to decide where they want to put the investment strategy. Almost everything that's been talked about was multimodal communication or privacy and security. All of them are important, including, for example, Dr. Kalika's comment that our rank is 53 in Hindi. It's even worse, actually. When I looked at the same data, but it's from a different perspective, there are about 7 million articles in Wikipedia, 7 or 8 million. The number of articles in Hindi are like about 110,000, about 1% or something. And Urdu is more, actually, and although in the ranking it looks like it's lower, the reason is it's also spoken in Pakistan and other places, so whatever reason, and the languages like Telugu and Tamil are half the size of Hindi articles, but they're all negligible, right? So one of the things we can do the things we have been looking at, saying, can we get crowdsourcing? How do we translate it and so on? But in general, population is very impatient. They don't want to wait 6 months or a year. And I think we need to look at the human behavior, how we deal with situations like that. I don't know about you, whenever I'm reading, even when I was young, when I would read English, I didn't understand half the sentences, but I nevertheless read it anyway, because I got some information out of it. So the important thing right now is to make the population aware and use existing data and existing tools and technology. There are things from both Google and Microsoft, and the simplest one I found is web translation. If you have an icon, you can just say, whatever I'm looking in English, translate it. It will be only 80% good. That is better than not having anything. And the same is true with speech-to-speech translation. If it is 30-40% word error rate, it'll be completely unintelligible. But if you can actually show any kind of advances at all, it might be useful. And so one of the things I've noticed even student doing is using the transcription as a guide. And so basically what I'm getting at is we need to convince the education system to provide basic digital literacy, that you can find any information you want. And from a linguistic, this panel point of view, the thing that is most important for us to do, I think, is what I call Indian language search engines. I should be, if I have a smartphone, I should be able to simply say, who is this person who is, Rafa Nadal or something? I see it in the paper. I don't know who he is. And so if I can say that, and then it goes and does the Indian English language search and comes back and translates it and shows me even 80% correct translation, that would be useful. It's not perfect. And so I think we need to kind of say, what are the sequence of things we want to do? There's nothing we are doing that's not appropriate, but we need to somehow prioritize. And somehow we need to kind of, rather than looking at it from a researcher perspective, look at it from the perspective of an illiterate person in a village. What does he care what we are doing about? Does he care about the things we're raising? What does he care about? And how can we help that particular challenge? I know, for example, they're all going to be shopping on Amazon and Flipkart and so on. And therefore, they will be building those engines, multilingual engines. They'll make mistakes, and ultimately, there'll be clarification dialogue and confirmation dialogue and all the other things, so that even if there are errors, the system will ultimately get the right answer, and they'll do it. And so anyway, I just wanted to kind of leave that thought, saying there's an education problem for the population, and prioritization of research investments for us. And this panel should discuss it, and then maybe come up with some suggestions to the Department of IT. Thank you, Dr. Pushpak.
Okay, thank you very much. So now we'll take a few questions, and cannot take all of them surely. There is a very large number of questions. Mitesh has sent me in 3 or 4 lots. So I'll take a few of them. There is one question I feel for such people. By the way, before we go to question answer, just want to mention to Professor Raj Reddy that I was leading the Indian effort on cross-lingual information access, building of Indian language search engines. And this was released in 2012 under the name of Sandhan. And then we were waiting for some industry to adopt it and take it to commercial level. So there was an effort of that kind. Okay, so now there is a question from somebody in the audience. How can startups go about building voice solutions when big corporations are struggling? They cannot gather the data. So what hope do startups have? So who would like to answer this? I have marked Jawahar and Vivek for this.
Okay, if Professor Jawahar or I can take it.
Yeah.
Okay, so thanks a lot for the question. Reverie was or has been a startup, and we have been through what you are asking. And in fact, the question, the problem becomes even more difficult for Indian languages, because even through the online sources or even open source communities, there is very little or probably nothing that is there. So yeah, large corporates also work towards that, and startups also do, but with a lot less resources. There are challenges around. So the way that we solved it was by actually adopting processes or ways how we will be able to get much better results with probably less than 10% or so of the data that you would typically use to train an English model or something of that sort. So being able to arrive at that requires you to understand a lot of things about how the whole process works. So today, the adoption of machine learning is probably being relied on by just feeding in a lot of data. But if you do understand it very well, because if data is the oil, and if you keep that really clean and you understand what the oil actually has, then you will be able to produce significantly better results. Just to tell you that when we released our ASR engines, the speech to text, and benchmarked with whatever publicly available engines from much larger organizations, our benchmarks were either better or matched them. So even with very little access to data.
Okay.
I have a small comment.
Yeah.
I think the word ASR or something may be very generic. So there may be many variations of it, and given the applications and the specific use cases. So even though big corporates may be struggling to build the generic ASR, there may be a lot of use cases where the startups or small players can contribute.
Okay, so Jawahar, this question is for you. In the talk of Dr. Jawahar, if I understood correctly, he is referring to data constraint scenario. Sir, can you please elaborate on DL techniques that should be explored in this domain?
Yeah, so I believe the question is about how can we build solutions when there are not enough data or in that domain or in that problem. So if you look at the example of the one of the early success stories in deep learning is from computer vision, where a large ImageNet, a huge data set was built, and that was used for solving one specific problem of, say, classifying 1,000 object categories. But very soon people realized that this solution gave a lot of byproducts which is useful for solving problem which the original network did not see. Or with an extremely small amount of additional data or training, you can adapt this solution to a new task or new domain with less effort. So this is how possibly we can move towards like languages or situations where the tons of data is missing.
Yeah, right. So I think we have to use a lot of linguistic clues for solving the data sparsity. Now this question, maybe Kalika, if you want to take it up. What is the global scope of working on Indian languages? For example, Tamil in Singapore, Urdu in Pakistan, Bengali in Bangladesh, and so on.
I don't know what they mean by scope,
Yeah.
but if the question is like, is there work being done in all these other places where Indian languages are spoken, then the answer is yes. Bangladesh does do a lot of work around language technology for Bangla, and so does Singapore on Tamil and Sri Lanka for Tamil, etc. So if that's the question, then yes, wherever the languages are spoken, people in that country are working towards thing. But if the question is that do we kind of have the linkages between India and these other countries where Indian languages are spoken to kind of build up on the technology, I don't think we have a very effective, there might be just one-off things, but we don't have effective network and infrastructure where we could leverage, all of us could leverage each other's work across countries. So I don't think that happens.
So I think the first part is true. They're taking baby steps to create small tools, resources. And I remember Bangladesh and Pakistan linking to Indo WordNet for Urdu WordNet and Bangla WordNet. So, so some small things are happening, that is true.
Yeah.
So now this question, maybe Bhiksha, if you could take, is there any effort to avoid misuse of AI? It's a very generic question, but you might have some thoughts.
There's actually a huge effort on this. I mean, even from, let me start with the voice perspective. In voice, just the European Union, there's a lot more work in Europe than in the US for whatever reason. But the European Union has actually been sending a lot of, has actually been focusing a lot of effort on trying to protect the user of AI. And so, for example, even for voice, there has been a commission which has been trying to, or a team that has been trying to study how voice can be misused and how it can be protected. This includes people with legal backgrounds, with governance backgrounds, and with technology backgrounds. This has actually expanded in scope to all kinds of AI. So if you just go on Google Scholar and look for papers on the topic, you can pick your keywords. You will find dozens or maybe even hundreds of papers, because as AI has become more popular and is being recognized more and more as a tool for changing society, what has happened, unfortunately, is that right along with us, the malicious actors have discovered them too. So things that you were not worried about 10 years ago, you are worried about now. And so there's both sides of the coin. How do you protect from misuse of AI, and how do you misuse AI? And I assume that one team is publishing less than the other, but there's certainly a lot of work on the subject.
Mm-hmm. And maybe you can continue, Bhiksha, because there is a question from Professor Raj Reddy. Can we use the concept of voice trace analysis for detection of deception as we do in forensic science by using AI?
That's actually again, that is open to misuse, but yes. And there was a very interesting paper by Gerald Friedland way back 10 years ago at this point, where he matched anonymous uploaders on YouTube and found their names by simply matching their voices to other uploads that they had made on Flickr. So this is, and so it turns out that you just have to expose yourself in one place, and then I can track you all over the place. You don't have to be 100% accurate. You know, this is the classic birthday attack. If I find a few people, that's good enough for whoever. If you're a malicious entity, if you're a government agency, or if you're a law enforcement agency, then you need a little more accuracy for it. But yes, this is actually being done.
Mm-hmm. Okay, great. So next question is for Professor Sangal. Please suggest the system which can ensure correctness of translation done by crowdsourcing or paid translators.
Well, ultimately, it is your users, their feedback is most important. So if your translated material is in use, then you will learn who are the ones who are doing a good job, who are not doing a good job. But even before that, evaluation of the translators through systematic methods is what we would need to do. So evaluation of the translated material and then by specific translators. So that would be one way. In case of voluntary translators, their credit, their reputation would be at stake. And in the case of people who are doing it for livelihood, they will lose money. So in either of the two cases, there would be things that will work.
Yeah. So I can maybe just add in 1 or 2 seconds that we conducted a challenger round for selecting people who could create parallel corpora. So this is not really exactly crowdsourcing, but we could set up a pretty robust evaluation system, adopting many different kinds of ideas, which can be shared later. So those evaluation systems are a combination of automatic, semi-automatic, and human evaluations. They can possibly provide a kind of safety net for quality. Now, The next question is a very interesting one. Maybe Kalika, Professor Sangal, you would like to take it. The essence of the question is, why not hit the root of the language tree and develop solutions for the root and then adapt them to languages which are descended from that mother language. So suppose we solve NLP problems for Sanskrit, and can we adapt those solutions to Bengali, Gujarati, which descended from Sanskrit? And there you can use possibly cross-lingual embeddings and so on. So interesting question. So would Kalika, you want to?
So I was thinking Professor Sangal could probably answer that.
Yeah.
Okay. So the way I look at it, I think what we haven't really tapped the full potential of is at least, if not the root, but at least typologically similar languages, and how we can kind of group languages in a meaningful way, and then use the deep learning part of the things to kind of work with that. So I think there is a lot of work that can be done in that area. We've done some work now, and we are seeing some positive results around that definitely there is a lot of scope of clustering typologically similar languages together. But
Yeah. Right.
the other way around, the way the world is going with the massive models, I don't know how to do that.
Can I try to answer that?
Yeah.
Okay. So there is a lot that you can achieve by trying to take commonalities from different languages, but it also depends on what is your exact use that you are doing it for. Languages are first, spoken, and therefore you would probably by taking commonalities, you will find a lot of benefit when you are trying to do anything on speech. But if you are also trying to do something on machine translation or anything on basically text, the expectation that working on Sanskrit or a root language, that is not so true. For example, Sanskrit might not actually prove to be a root language at all, because if you just look at the grammar, so between singular, dual, and plural, there are no other Indian languages they actually have that. So, so similarly, let's say if you were to compare Hindi with, let's say, other languages, you have a pronoun in other languages which can be gender, sorry, nouns that are gender. But in Hindi, you will have adjectives and verbs that are that have gender. So they will tend to interfere if you are trying to base one thing and extend it there. So like Kalika mentioned, that you should look at being able to group based on similarities. That can give you a lot of benefit. And but without that, if you are just trying to implement by considering there are roots and then there are derivations, then you might not get the right results. You can write algorithms that will be able to establish the similarities as well.
The 2 points I wanted to say here, one is that at a deep level, there are a lot of similarities amongst Indian languages, typological. They come from typology, but they also come from the fact that we seem to be having a common mother language for many of our languages. So what we discover there, what we do there, that benefit comes to us. So that was the idea behind computational Paninian grammar. And those benefits will come for all processing of other Indian languages. Secondly, when we go for translation and translation of technical terminology, then the fact that we have a common etymology, we have a common source language, or words that are chosen in such a way that many of those things can be transferred to other Indian languages. So we can come up with a common technical terminology which is useful and also available for other Indian languages. So we can take advantage of that also. So this is something which is certainly worth looking at.
Yeah. Yeah, so surely a very interesting question. And I don't think we have more time for taking up more questions. Only point I wanted to make about this question is that there are three important inputs coming from both machine learning and linguistics. Linguistics, you have these tadbhav and tatsam words, which get borrowed from quote unquote mother language. So tadbhav and tatsam words are important to keep in mind. And machine learning gives you the transfer learning framework, which is very pertinent here. And finally, subword based NLP is very effective there. If you break a word into its parts, then you see common substring. So Bangla jabo and Hindi jaunga, they mean the same thing. Only there is suffix difference of unga and bo. So subword based computation also can help a lot there. But it's a very nice question, and a lot of things can be said about this. But now, in the interest of time, we should really give the floor to Mitesh. Mitesh, will you operate your slides?
Yes, sir, I'll operate.
You'll operate. So I'll just introduce you. Just give me 2 minutes. One minute, Mitesh. Yeah. Mitesh, just give me 2 minutes.
Sure, sir.
Just came very late. Okay, I don't think I'll share the screen. So Dr. Mitesh Khapra is an assistant professor in IIT Madras, and he is also associated with the Robert Bosch Center for AI. He has co-founded 2 startups. One of them is AI for Bharat, which he will talk about during his demonstration. Dr. Mitesh Khapra is already very well decorated. He has got the Promising Young Faculty Award at IIT Madras, and also got Professor Yagnanarayana Award for Excellence in Teaching and Research. Before that, he was awarded the Google Faculty Grant. Before joining IIT Madras, Dr. Khapra was in IBM, working for about 4 years there, and he did his PhD and Masters from IIT Bombay. Over to you, Dr. Mitesh Khapra.
Thank you, sir. So is my screen visible?
Yes, it is visible.
Okay. So I'm going to talk about our initiative called AI for Bharat, and in particular about our work on Indic NLP as a part of this initiative, right? And this is a website, the URL for which is mentioned here, which we want it to become the hub for Indic NLP resources, data sets, and tools. And we're really looking at it becoming a common place where all the industry, government, academia, students, everyone comes together and works towards building data sets and technologies for Indian languages, right? So quickly about the founding team. So this is me, Pratyush, and Anup. Pratyush and I are faculty members at IIT Madras, and Anup is a senior applied researcher at Microsoft with a lot of experience in NLP. And both Anup and I are Professor Pushpak's students. And this is our philosophy, right? We want to harness AI for serving Bharat. That's the philosophy on which AI for Bharat was founded. And now quickly talking about the panel discussion, right? So we had an excellent discussion on what is the state of NLP for Indian languages today, and where are we headed, right? What's the way forward, right? And the problem of data came up in all the presentations, right? Starting right from Professor Raj Reddy's talk, where he said that we have the technical know-how, we know how to build these tools. The problem is we don't have data for Indian language, right? And that's what everyone is recommending. We should curate data sets for Indian languages. And once we have these data sets, we need to innovate. We need a platform for a common platform for evaluation and tracking progress across multiple tasks in multiple languages, right? And again, one theme which came up frequently during everyone's presentation was that there's a lot of commonality across languages, but there's also some difference. And hence, it's very important to exploit these commonalities, but while also independently track the progress on these tasks, right? You cannot say that, okay, I've solved the task of sentiment analysis for Hindi, and Hindi, Gujarati, and Hindi and Marathi seem to be very similar, so I've solved it for them, right? That's not the way. You could exploit some of the similarities, but you need to also track progress on these languages independently, right? And the third is to create an ecosystem of stakeholders to create and deploy solutions for the country at large. Right? This is where startups, industry, academia, government, everyone comes together, right? Because government's reach, no one can match. The pace at which startups move, no one can match. The industry brings in a lot of experience of building deployable solutions, right? We have more than 30 plus years of IT experience on building large-scale solutions, and that's what is required, right, to tackle this problem. And academia, of course, brings in the research aspect to it, the expertise in developing the solutions which have been built over years of study in this field, right? So all of this needs to come together. This is what the panel is recommending, and this is exactly why AI for Bharat was founded, with these exact goals for making way forward for Indian NLP, right, to curate, innovate, and build. And now I'll just quickly talk about what we have done so far as a volunteer effort. Again, a lot of partners from different institutes and different places who have volunteered for this effort. And we'll talk about some of the work that we have done in serving underrepresented languages, right? The first step there is to document underrepresented languages by building a catalog, right? So that's very important. There is no publicly available catalog of all the resources available for Indic languages. Right? So today, if you are a startup or the government and you want to find out which are the languages which are not being served, there's no catalog which existed. So we have built something as a part of AI for Bharat, and I'll just walk you through that tool, right? So this is the data explorer that we have. And you can see here, is my screen visible? Do you see the data explorer?
Yes, I see the link.
Yeah.
Oh, no, I've moved to the web page. Okay. Let me just see. Yeah, so this is the data explorer that we have, which tells you about the current state of Indian LLP. These tracks resources and data sets available for different languages across different tasks, right? So you have monolingual corpora, parallel transliteration corpora, word similarity, word analogy, and so on. I hope you can see this table with a lot of check marks and cross marks, right?
Yeah, we can see it.
Yeah, and this is for all the different tasks that are there within the NLP spectrum. And you can see now it's very easy from this table to identify the languages which are being underrepresented, right? So now you can see that there are a lot of cross marks for Punjabi, Gujarati, Oriya, Assamese, Kannada, Telugu, Malayalam, but some of the other languages like Hindi, Bengali, Tamil are doing well across different tasks. But this well is also a bit relative, right? They're doing well in relation to the other Indian languages, but they're not as well off as some of the Western languages like English, right? So that's something that we have been creating a detailed catalog of all the resources for Indian languages. And you can see here, you can go to this GitHub page where for every resource, we have a link for that resource. So you could download the data from these resources, right? The second thing, okay. Second thing which is important is to develop input tools for creating content, right? So I think, again, a lot of the panel members touched upon this topic, that there are not enough content in Indian languages. There are a lot of users wanting to see content in India, in Hindi or in say Maithili or Konkani, but there aren't enough tools for creating this content, right? So how do you get this content? If I am a blog writer in Konkani, what are the tools available for me to write a blog on my own, right? So that's where again we have been working with Google and with Pratham Books. So Pratham Books is the largest education NGO in India, and they do an excellent job of creating stories in multiple languages, right? They cover more than 250 Indian languages, and in particular, they focus on underrepresented languages like Bodo, Konkani, Maithili, where enough resources are not available. And they take storybooks in English and then translate them to these languages. And they hire annotators to do that, but these annotators need certain good input tools so that they can do this translation, right? So we worked with Pratham, and we developed transliteration tools for certain underrepresented languages. So I'll talk about our work on Konkani and Maithili. So once again, I'm sharing the demo tool that we have. And I would like to mention that this the UI is based on the open source Varnam web, which is available. But the models which are being used, they are developed by us as a part of AI for Bharat. So I'll just show you one example from Konkani first. So this is Tumi Konkani Uloitat. Okay, so this is how a Konkani speaker would write it, which is Uloitat. So you have an O here. But once the word gets transliterated, right, it doesn't have the O matra. If people who can read Devanagari would understand that. It doesn't have the O matra, but the speaker would prefer to write it as Uloitat because that's how they say it in the language, right? Now, such tools, if you say, okay, this is Devanagari, let me just use the Hindi input tool for this, or even the Marathi input tool for this, it will not get the word correctly. That is a case where all of these languages share a lot of commonality. There are a lot of vocabulary which overlaps between Konkani and Marathi, but still there's a very language-specific aspect which needs to be addressed here. The pronunciation is a bit different. The way native speakers prefer to write it in English is a bit different. And if you use a Marathi tool for that, it will not really do the job, right? And a similar example I have for Maithili, which is again an underrepresented language. And I've taken the sentence here because I don't understand Maithili. So I just wanted to have the sentence in front of me. And this is Ehi Sadaka Bha. Okay. Ka. So now I'll just not type the entire thing in the interest of time. But these two words that you see here, right, which is Bha and Ka. And if you noticed, I typed it as BHAA and KAA. Now, instead of Maithili, if I had said, okay, I can use the Hindi input tool for it, which is available on Google, whereas both Maithili and Konkani are not available on Google, then it wouldn't have produced this S-shaped character that you see here. It would have actually produced the A matra, which is common in Hindi. But a Maithili speaker would almost get offended by that because that's not what he or she would expect. And they would want this spatial character to show up, right? So again, this is a case where you really need to develop tools which target these underrepresented languages instead of saying that, okay, here's your closest cousin. Why don't you use tools for which are available for that language, right? So continuing on that.
Mitesh, it seems we have only 2 minutes left.
Okay.
So
Yes, I'll probably not give any more demos. I'll just talk about the tools that we have developed. And as I mentioned, this transliteration tool was developed on top of the APIs provided by Varnam, but the model is what we have built. Similarly, for enabling annotations in Indian languages, right? So now if you want to create annotated data, sentiment analytic data, or translation data, you need certain tools. So this is again that we have something that we have developed on top of Easy Annotate, which was some APIs provided by DataTurks, but now we have adopted it for Indian languages, supporting Indian languages. So now you could use this tool to type in Hindi or any of the Indian languages and create data in those languages, right? And the third part is to build models and evaluation benchmarks to track progress. So very recently, we have released these two tools called IndicBERT and IndicGlue, which is on the lines of the deep learning based research, which is happening in English, Chinese, and other languages, where they have these massively large BERT based models, which are able to achieve state of the art results in a large number of tasks across languages, right? But such models were not available for Indian languages. They again required a lot of data to be curated. So we have done that. And all of this has been released as open source on our platform, which is the URL is here, indicanlp.ai for bharat.org. Sorry, I can't go in more details at this point, but I have, you could visit these websites and you could get all the information there, right? So that's all I had to say. Please visit indicanlp.ai for bharat.org. And this is an example of Pratham, right? So this is the book that they are translating, sorry. And the tool which you see here is the one which is developed by us, and they're using it to translate it to Maithili. So that's all. Let it all come together. There's a call to all of us from academia, industry, startups, government to come together and make India ready for the AI age. And please contact us if you are interested in contributing to AI for Bharat. Thank you.
Thanks a lot, Mitesh. I don't think we have really time for question, answer, and so on, but if there is anything very quickly from anybody.
Dr. Pushpak, I have a small comment.
Yeah, please.
To Dr. Mitesh. I have a recommendation. You decided that the right transliteration from Konkani is to Devanagari. And I had the experience of trying to demonstrate the mistakes Microsoft was doing for the international researchers at Microsoft. And they couldn't read Devanagari, they couldn't read any of it. The simplest thing turned out to be to use English language transliteration, which is what English newspapers use in India also. When they want to say something in Hindi, they transliterate it. They don't put, Devanagari letters. They transliterate it into Roman letters. So you might consider, you can have both, Devanagari and English transliteration. But the simplest thing for a global use would be to use English language. Google Translate, for example, Google translates anything you say in any language into some equivalent English letters in some sense. That's all my suggestion.
Yeah, sir. So here the idea is that, of course, you could type it in Romanized text, right? And you could just keep it as English, and many people would really understand that because most teachers might be aware of English. But the idea here was to really represent it in the local language. And the Konkani script is the Devanagari script. They just use the same script. They don't have a different script. And they wanted the books to be in authentic Konkani. So they didn't want it to be in the English language or Romanized. That's why they needed this tool where the translators can enter this data. So that was the concept.
So the problem you have is there is a large Indian diaspora in USA and other places. Even their kids don't know how to read Devanagari. And they only, so if you just transliterate it into English, since they speak Hindi at home or Telugu at home, they can read the Telugu words in English and understand what you're saying. Anyway, this is just a comment on what is the conventional transliteration standard you should use, but you should pick whatever you feel comfortable with.
Thanks.
Okay, so I guess we should really stop now. And it was an extremely rich discussion, very, very fruitful, very useful. And I would like to thank Professor Raj Reddy, Professor Rajeev Sangal, my co-panelists, Dr. Mitesh Khapra, and all the audience for making this event a success, I would say. We really had very good meeting of mind and exchange of ideas. Thank you very much, and good night to Indians.
Thank you. Thank you, Pushpak.
Thank you.
Thank you.
Thank you.
Thank you, Pushpak. Thank you, everyone.
Thank you very much. Bhiksha, good afternoon maybe for you. Thank you. Bye.
Thank you, everyone. Thank you.
Professor Raj Reddy, bye. Thank you.